Hello, I'm Nishit, and the market is down by 30%. It's a market crash. I'm just kidding. So, today I'm going to talk about the project that I have recently done. It's about the Detroit traffic crash. The main goal for this project was to predict the presence of and drug, alcohol or drug, in the person that is involved in the crash. The main reason for introducing this project was the Fourth Amendment, which says that the police is not allowed to take any kind of drug test to the person who is involved in the traffic crash. For that, the police has to have some search warrant or to develop some probable causes through which they can take the test. So using the historical data and the machine learning models, we can eliminate the time of developing the probable causes, and it can be a good help to the system. So regarding the data description that we have taken, so it's about the Detroit city crashes, which has 142,000 records with 36 columns. The interpretation of some of the features in this data was difficult, as the documentation of the features wasn't given that properly. We tried mapping some of the features with very analogous data, such as Maryland crashes data. On the exploratory data analysis part, like we got to know that more youth crashes has found than the elder people, but the overall proportion was very similar with each other. We got to know that more youth people are involved into the drug, which caused the crashes. Regarding the timing of the crashes, it was mostly happening between 2 p.m. to 6 p.m. But with the people which consume the alcohol or drug, their crashes were mostly in the midnight or in the early morning, before the early morning. With talking about the modeling, we created the 8 classes using 3 features in which we separated the elder and youth. So we got the accuracy of 86%, but the model didn't perform well with other classes because of the low variance in the data. So we tried balancing the whole data using the SMART, using the k-nearest approach. So, and tried to model the same model again. So at that time, we got the accuracy of 38%. So it is because of the correlated classes, and model gets confused with the correlated columns. So I decided to just mainly focus on the 3 classes, that is alcohol, drug, and the clean. And the best estimator for this was the logistic regression with the solver of C.G. Newton. The reason for choosing this solver was it has a very low amount of deviation in overall all the scores as compared to other models. And like seeing the random forest, such a strong algorithm can memorize the training data, and there are high chances that it can perform very bad in the unseen data. So that is why we didn't choose this algorithm. Overall, in the conclusion, we predicted the presence of drug and alcohol with a good amount of accuracy. We tried increasing the variance in the data using the SMART. And regarding the synthetic values of drugs, there were very few amount of cases of the drug, mainly because of the tests weren't taken because of the Fourth Amendment that we talk. But if the patrolling is increased in the midnight or early morning time, maybe we can get more amount of drug-related crashes for the data. So yeah, for potential future steps we can take advice from subject matter expert for knowing the significance of the features and their values. And that is it from my end. Thank you for driving safely.